Here we have a 2.6 kilogram stone, so that is obviously a mass, at the end of a 0.74 meter rope. If we look at the picture here, that 0.74 meters is the value of R, isn't it, for our stone that's being whirled in a horizontal circle at a constant rate. The period is 1.1 seconds. Period is symbolized by capital T, we know. And what we want to know is, what's the tension in the rope? Well, the tension in the rope, this is the centripetal force that's making the stone go in a circle. So that's what we need to find here. We need to find the centripetal force. We wrote down in a previous lesson some possible equations that we could use for centripetal force. One is the mass times the centripetal acceleration. Since the centripetal acceleration is the tangential speed squared divided by r, we could write mvt squared over r. Or since the centripetal acceleration is r omega squared, we could use that as well. Well, let's see what we've got here. We know that omega is angular displacement divided by time. The angular displacement of one time around is 2 pi radians, and the time for one time around, we're told, is 1.1 seconds. So I think if we take 2 pi divided by 1.1 seconds, that's going to give us the value of omega. We know what r is, and we've got the mass. I think that should do it for us. Let's see if that gets us where we want to go. Let's take the mass, 2.6 kilograms. I'll go ahead and include the units. The value of r is 0.74 meters. And then, one more time, omega is angular displacement divided by the time that is associated with that displacement. It takes 1.1 seconds to go one time around. But that quantity, according to the equation, needs to be squared, so don't forget to do that. If you type that in, you're going to get to two significant figures, 63 newtons. And here again, we run into the case where we see that a radian is kind of like a nothing. Because if you look at the units here, we have kilograms, we've got meters, we've got radians squared, and we have seconds squared. And if you look at Newton's second law, let me scribble it over here on the left side of the page. Force is in newtons, mass is in kilograms, we know this already, and the acceleration is meters per second squared. So you can see that a kilogram meter per second squared is the same thing as a newton. Now look at what we have in our case here. There's a kilogram meter per second squared. That's a newton, but then it looks like it's multiplied by radians squared. Here again, we're seeing that a radian is kind of a nothing unit. It's a unitless unit, which completely falls away in this case. 63 newtons is the tension in this rope.